Using armor-clad interlocking cable, often referred to as AC cable, for feeders supplying electrical panels within a hospital environment is generally considered a violation of electrical codes and standards. Hospitals and healthcare facilities have stringent requirements to ensure the safety and reliability of their electrical systems because any disruption or failure can have critical consequences for patient care. Firstly, the National Electrical Code, or NEC, which is widely adopted in the United States, has specific articles addressing wiring methods permitted in healthcare facilities. These articles typically place restrictions on the types of cables and wiring methods allowed, particularly for essential electrical systems like feeders to critical care areas or life support equipment. Secondly, AC cable might not meet the requirements for grounding and bonding necessary in hospital settings. Hospitals require robust grounding systems to minimize the risk of electrical shock and to ensure proper operation of sensitive medical equipment. The grounding capabilities of AC cable might not be sufficient to meet these demanding requirements, potentially leading to safety hazards and equipment malfunction. Thirdly, the NEC often requires that wiring methods and patient care areas be installed in metal raceways or be specifically listed for use in healthcare facilities. Metal raceways provide a physical barrier that protects the wiring from damage and also serves as an effective grounding path. AC cable, being a flexible cable, might not offer the same level of protection or grounding capability as rigid metal conduit, intermediate metal conduit, or electrical metallic tubing. Fourthly, the presence of sensitive electronic equipment in hospitals necessitates minimizing electromagnetic interference, or EMI. Certain wiring methods, such as those installed in metal raceways, can help shield the wiring from external EMI and prevent interference with medical devices. AC cable might not provide adequate shielding against EMI, potentially affecting the performance of critical medical equipment. Fifthly, hospitals often have fire rating requirements for wiring and cabling, especially in areas where patients are present. The NEC specifies requirements for fire-resistant cables and wiring methods to prevent the spread of fire and to ensure the integrity of electrical systems during a fire event. AC cable might not have the necessary fire rating to meet these requirements, particularly in patient care areas. Sixthly, healthcare facilities are subject to inspections and approvals by regulatory authorities such as state health departments and accreditation organizations like the Joint Commission. These authorities enforce strict standards for electrical safety and compliance. Using AC cable for feeders to electrical panels could result in non-compliance with these standards and potential penalties or corrective actions. Seventhly, the design and installation of electrical systems in hospitals should be performed by qualified and experienced electrical engineers and contractors who are familiar with the specific requirements of healthcare facilities. These professionals can ensure that the wiring methods and materials used comply with all applicable codes and standards. Eighthly, when selecting wiring methods for hospital electrical systems, it is essential to consult the NEC and other relevant standards to determine the acceptable options. The NEC provides detailed information on the types of cables and wiring methods permitted in healthcare facilities, as well as specific requirements for grounding, bonding, and fire protection. Ninthly, alternative wiring methods that are commonly used for feeders in hospitals include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and cable types specifically listed for healthcare facilities. These wiring methods offer superior protection, grounding, and fire resistance compared to AC cable. Tenthly, it is important to note that the specific requirements for wiring methods in hospitals can vary depending on the location, the type of healthcare facility, and the applicable codes and standards. Therefore, it is always recommended to consult with a qualified electrical engineer and the local authority having jurisdiction, or OJ, to ensure compliance with all relevant regulations. In summary, using AC cable for feeders to electrical panels in a hospital is generally not permitted due to the stringent safety requirements and specific wiring method restrictions in healthcare facilities. Compliance with the NEC and other applicable standards is essential to ensure the safety and reliability of electrical systems in hospitals and to protect patients, staff, and visitors from electrical hazards. It is essential to ensure proper grounding, minimize electromagnetic interference, and meet fire rating requirements. Consider these factors for compliant electrical system in healthcare. Wire and cable management are vital for safe hospital operations. Always consult with qualified professionals for electrical work in hospitals. Hospital electrical systems need routine checks and upgrades. Patient safety depends on reliable electrical systems. Code adherence is crucial for hospital electrical installations. Electrical risks in hospitals require special precautions. Electrical safety education is important for healthcare staff. Hospitals should have detailed electrical safety plans. Emergency power systems are critical in hospitals. Hospitals need backup power for critical operations. Power failures in hospitals can have serious consequences. Hospitals must maintain their emergency power systems. Electrical codes provide safety guidelines for hospitals. Hospitals should follow NEC standards for electrical safety. Hospitals must inspect their electrical systems regularly. Preventative maintenance can improve electrical safety. Hospitals need to train staff on electrical safety. Safety inspections can uncover potential hazards. Electrical grounding is vital in healthcare facilities. Hospitals must properly bond their electrical systems. Bonding prevents electrical shock hazards. Surge protection is important for sensitive equipment. EMI can interfere with medical device operation. Hospitals need to shield equipment from EMI. Fire-resistant cables prevent fire spread. Hospitals must use fire-rated wiring methods. Regulatory authorities oversee hospital compliance. Hospitals must meet accreditation standards. Qualified professionals design hospital electrical systems. Electrical contractors install hospital wiring. Proper design ensures reliable power distribution. Hospitals need a reliable power source. Consider available options when designing electrical systems. Choose the best wiring methods for each application. Evaluate different types of cables and conduits. Use appropriate fittings and connectors. Ensure proper support for wiring and cables. Follow manufacturer instructions for installation. Use the correct tools and equipment for wiring. Employ safe working practices when wiring. Double-check all wiring connections. Test all wiring before energizing circuits. Label all circuits and equipment clearly. Keep accurate records of all electrical work. Update electrical drawings as needed. Maintain a clean and organized electrical room. Do not overload circuits or panels. Replace damaged wiring and equipment promptly. Invest in high-quality electrical components. Seek expert help for complex electrical problems. Comply with all local and national electrical codes. Safety is paramount in healthcare environments. Choose materials that are safe for patient care areas. Ensure proper ventilation for electrical equipment. Keep electrical equipment clean and free of dust. Monitor electrical systems for signs of overheating. Invest in thermal imaging for electrical inspections. Conduct routine insulation resistance testing. Ground fault circuit interrupters, or GFCIs, protect against electrical shock. Arc fault circuit interrupters, or FCIs, prevent electrical fires. Use appropriate personal protective equipment, or PPE, when working with electricity. De-energize circuits before working on them whenever possible. Follow lockout/tagout procedures to prevent accidental energization. Keep a safe distance from energized equipment. Be aware of potential electrical hazards. Take precautions to prevent electrical accidents. Electrical safety is everyone's responsibility. Report any electrical hazards immediately. Stay informed about electrical safety best practices. Continuously improve electrical safety procedures. Make electrical safety a top priority. Implement comprehensive electrical safety programs. Conduct regular electrical safety audits. Address any electrical safety deficiencies promptly. Provide ongoing electrical safety training. Promote a culture of electrical safety. Encourage employees to report safety concerns. Recognize and reward safe work practices. Learn from past electrical incidents. Share electrical safety lessons learned. Use technology to improve electrical safety. Invest in electrical safety equipment. Maintain electrical equipment properly. Dispose of electrical waste safely. Comply with environmental regulations. Protect the environment from electrical hazards. Promote sustainable electrical practices. Conserve energy and reduce waste. Use renewable energy sources. Support energy efficiency initiatives. Reduce carbon footprint. Be a responsible environmental steward. Promote a healthy and safe workplace. Protect the health and well-being of employees. Prevent workplace injuries and illnesses. Create a positive and supportive work environment. Promote work-life balance. Encourage employee engagement. Value diversity and inclusion. Foster a culture of respect. Provide opportunities for professional development. Invest in employee training and education. Recognize and reward employee contributions. Celebrate successes and achievements. Build a strong and cohesive team. Communicate effectively with employees. Listen to employee feedback. Address employee concerns promptly. Resolve conflicts constructively. Promote teamwork and collaboration. Encourage innovation and creativity. Empower employees to make decisions. Trust employees to do their best. Support employee growth and development. Invest in employee well-being. Create a workplace where employees thrive. Promote a positive and productive work environment. Foster a culture of excellence. Strive for continuous improvement. Achieve outstanding results. Make a positive impact on the community. Be a responsible corporate citizen. Uphold ethical standards. Act with integrity. Be transparent and accountable. Build trust and credibility. Maintain a strong reputation. Be a leader in electrical safety. Set the standard for excellence. Inspire others to achieve greatness. Make a difference in the world.